In these practice problems, we're going to look at our reaction and make a judgment about which of the possible reactions will occur with our alkyl halides. Is it SN1, SN2, E1, or E2? And then we also want to draw the products for those. So we're going to use our flow chart. Our very first question is whether or not our reagent is negatively charged or neutral. We've got a neutral reagent here, and it's an alcohol, so it's the kind of reagent that promotes SN1 and E1. Still got to check our alkyl halide structure, and it's tertiary. So that tells us indeed a reaction can occur, and it'll be some mixture of SN1 and E1. And we still want to be able to draw the products. So for the SN1, we're going to substitute that nucleophile for the halogen. And remember, we always lose that proton in these SN1 substitutions. We're also going to get elimination products. So we have 3 different beta carbons. Because 2 of these are both the same, whether or not you lose a proton from this beta carbon or this beta carbon, you in fact get the same product. So let's draw those products. There'll be one possible alkene, and the other possible one would be from pulling a proton off of that beta carbon. So we'd get our alkene between that beta carbon, right, and the carbon where the halogen leaves. So that would be our other alkene. So there are all 3 possible products. We could say that one's the major because it's the SN1, and we typically get more SN1 than E1 in these reactions. Here we've got a negatively charged reagent. So we're heading down the SN2E2 path. Here we've got a secondary alkyl halide. So we can't make a judgment about whether we'll get more SN2 or E2. So we'll just say a combination of the 2 and still make sure that we can draw the products there. So if it's the SN2 product, we're going to substitute our nucleophile here, where our nucleophilic atom becomes bonded to the carbon where the bromine leaves. And since it's SN2, you get 100% inversion of configuration. So I can switch the dashed and wedged bonds there. Now for the E2, I've got a beta carbon here, right? And I've got a beta carbon there. But there are no hydrogen atoms on that beta carbon there, so you cannot get the elimination product, right, where you would get the double bond between this beta carbon and your alpha carbon. You can only get the elimination product between this beta carbon and your alpha carbon. So my elimination product would look like that. Okay. Here our reagent is negatively charged. We've got a primary alkyl halide, right? And that would suggest then that our product is mostly going to be SN2. So we'll just draw the SN2 product. And finally, We've got a negatively charged reagent and a tertiary alkyl halide. So we would predict predominantly E2, extensively E2, so we won't even worry about drawing the other substitution product. Again, we have to think about the different alkene products. That's a beta carbon, that's a beta carbon, there's a beta carbon. But because these two alkyl groups on either side here are the same, right? They're both ethyl groups. That means whether you eliminate or pull a proton off that beta carbon or that beta carbon, it doesn't matter. You'll get the same product. So I'm just going to do skeletal structures on this one. We'll draw them. So the products that I would get, there would be one possible product. Now, since this is an internal alkene, again, we have to think about stereoisomers. So the other stereoisomer to that one would look like that. And then finally, the third product would be the one where you pull a proton off of this carbon here. And do the elimination. So that would be the third possible product. As far as which would be major and minor, this guy, because he only has 2 alkyl groups, and both of those have 3 alkyl groups, this one would be minor. Of these two, looks like the one that gets the largest group trans to one another is this one here, so it would be major. And this would be, well, we won't call it minor. It's the one in between. So our distribution of products would look like this. Okay, well, have a go at some of those and let me know if you have any questions.